Hello everyone, so today we are going to keep working with arithmetic sequences, and what we're going to focus on today is how to write the function for an arithmetic sequence from the arithmetic pattern. So let's go ahead and get started. So looking at what we have here, so we're going to find the function, and we're going to find the number of units in the 10th figure and the 100th figure. Remember, we wouldn't want to have to keep adding 1 or adding 7 or adding a number to get to the 10th pattern, to the 100th pattern. It would take way too long. So the question is here, can we find an equation to find the number of units in an arithmetic sequence? And of course the answer is yes to that. And in this case we are going to be looking at a linear pattern. So we're going to find the function for each one for the 100th and 10th figure. How are we going to do this? So remember, each arithmetic sequence is a linear function because it has a rate of change that is the same throughout the pattern, meaning it adds by the same amount. Therefore, it's going to be a linear pattern if we go ahead and graph it, which we can write a linear equation. So y equals mx plus b, or in function, f of x equals mx plus b. So this only works for arithmetic sequences, not geometric. So let's go ahead and do this. So these are the same ones we've been doing from before, the same pictures and the same patterns. So we've seen this one twice already in your assignment and in last class's notes. So let's go ahead and start with pattern number 1. So we know that this one is growing by 4 on the output, where the input is growing by 1. So we know our rate of change, or our growth value is 4, where our start value, or our y-intercept, starts at 0, but we don't have the 0 when we're talking about 0 from figures, so we're going to have to backtrack. So to go backwards, we're going to have to subtract 4 from the 7, which means at our 0 term, we're going to subtract 4 to go backwards. We're going to get a 3. So our y-intercept, or our start value, is at 3, where our function is going to be 4x plus 3. Remember, the rate of change, or our growth value, always has the variable because that's the number that repeats, which means we multiply by 4. So let's go ahead and find the 10th figure and the 100th figure. So we're going to use our function. We're just going to plug in the number 10. X equals to 10, so f of 10. 4 times 10 plus 3, that's going to give us 43, because 40 plus 3 is 43. What about the 100th figure? So again, without having to write 100 numbers out, we can just plug in the number 100. So we add 4 100 times, which is 400, but we started at 3, so we add those 3 extra units, which gives us 403. So you guys did the 10th figure on yesterday's classwork, but you just wrote out the list. So instead of having to write out lists for future reference, we can just use our function if we have one, when it's an arithmetic pattern. So same thing for number 3. We know this one is decreasing by 2, so we're moving 2 little lines. We're going to backtrack and find our 0. We know our rate of change is -2. So going backwards, the opposite of subtracting 2 is we're going to add 2 to go backwards. So that means we're going to be at 20 for figure 0. That's our start value, or our y-intercept. So my function is going to be -2x for my change plus 20. Now we're going to find the number of lines in figure 10 and in figure 100. So when we plug in our 10, we get -20 plus 20, which gives us 0. Let's go ahead and do the 100th figure. We're going to plug in 100 now. So -2 times 100 will give us -200 plus 20. And that's going to give us -180. But wait a minute, this doesn't make sense. We're taking off little lines. So how can we have -180 lines? So in this case, we would reject this answer because it doesn't make sense to have -180 lines. In this case, we would just say it's 0 because this is a finite figure. We can only remove lines till we run out of lines. So we wouldn't go into the negatives here. So just kind of being aware of the situation here helps. Let's go to the next pattern. Again, we had this one in our classwork as well. This is another arithmetic sequence, and in this case, we went from 4 to 6 to 8 to 10. Here we are changing by 1 at the top, where at the bottom it's changing by 2. So it increases by 1 on the top by figure number, units change by 2. We're adding 2 circles. So our rate of change is just 2. Let's go back to do our 0 figure. So if we're to go backwards and subtract 2, we'd end up with 2. 4 minus 2 is 2. So that's our start value. Function is 2x plus 2. So go ahead and figure out the 10th figure and the 100th figure, and then come back and check your work. Pause the video. So your 10th figure, you should have gotten the following: 20 plus 2, 22 in the 10th figure. And if you keep adding circles to the 100th figure, how many circles would you have? You'd be adding 2 circles 100 times, plus the 2 original circles, which gives you 202 circles. So this is an infinite figure because you can continue to add circles forever. So this is just a quick recap on how to write the function from a sequence using your table. So again, you wouldn't want to keep writing numbers out generally. So go ahead and start your practice pages. Good luck.